Okay, so kita akan ada sesi untuk kita warm up lah. Okay, kita warm up sebelum kita mula masuk ke main topik ataupun main presentation. So mohon tuan-tuan dan puan-puan untuk join us dekat slido.com ataupun di slido.com sekiranya masuk through direct ke slido.com boleh type dia punya kod #PQEE dengan passcode TNB 123. Dan sekiranya scan QR code, masukkan password yang tertera pada skrin masing-masing. Okay, so kita nak ada some sesi untuk kita panaskan enjin sebelum kita bersedia menerima presentation daripada dua speaker kita pada pagi ni. Okay, hopefully kita ramai yang dapat join Slido ni. Okay, so soalan yang pertama adalah kita nak tahu macam mana tuan-tuan dan puan-puan pagi ni. How are you today? Okay, okay, good. I'm fine. Boleh tahan. Energetic. Okay, that's right. Okay, I'm fine. Excited, PQ free. Alhamdulillah, PQ free. Sihat, sedang berpuasa. Okay, selamat berpuasa pada siapa yang berpuasa daripada kemudian very good. Oh, busy. Thank you. Yang busy dapat juga luangkan masa sikit dengan bersama kita pada pagi ini. Great, alhamdulillah. Excellent. COVID positif. Oh, semoga cepat sembuh. Semoga cepat sembuh. Okay, hopefully dia punya simptom tu tak teruk lah. Ya. Kita ada 42 yang join kita dalam Slido. Out of 130 plus tadi. Okay, ada lagi yang berusaha untuk masuk. Tak apa, kita go to next question ataupun next kita kata item. Okay, kita nak tahu you all adakah telah menjadi CIRED member. Alright. Wow. Okay, interesting. Setakat ni 8% CIRED member, 7% CIRED member. Okay, out of 48 yang join Slido kita, kita ada 8% CIRED member. Okay, hopefully after this session yang 93% ni bolehlah dapatkan form dan daftar sebagai CIRED member. Okay, next. Are you aware of existence of CIRED Malaysia? Okay. So nampak macam balance. It looks like majority macam not really aware. Okay, so we take note on that. Okay, so next, which industry are you attached with? Okay, kita nak tahu how many daripada TNB, how many daripada industri. Alright, kita tengok 50 plus tadi yang masuk Slido. Kita nak tengok. Okay, others is 50% right now. Okay, 60 is others, TNB almost 27, oil and gas is 8, academic is 5, telco no. Okay. So this is a good sign because kita ada participant yang luar daripada TNB ramai. Okay, it's good. Okay, the next one is, in my work experience, kita just nak gauge sebelum kita mula. In your ataupun in my work experience and environment, PQ is what? PQ is a serious issue. PQ is an issue of some concern, or PQ is maybe an issue of concern, not an issue at all, or we have no idea about PQ. Okay, we just want to gauge the participant knowledge or the participant experience on PQ before our speakers address this issue. Okay. (71) in slide 72. Okay. Okay. Before, so most of us, 42%, saying that PQ is a serious issue of concern. Okay, okay, we take note on that. Okay, where do you get this webinar information? All right, friends. Email, friends, message, or media social is quite balanced. Okay, looks like a balanced mix of channel. You'll get the information about this webinar. Okay, all right. Okay. Last warm-up session kita. In one word, what do you expect from this webinar session? Okay. We want to hear from you before we start our main presentation from the speakers. Okay. Enlightening. Okay. All right. Good knowledge. Knowledge, pandai, networking, fruitful. New solution, informative. Okay, networking, all right. All right. Enhancement, clear. A lot of new information, understanding. Better understanding, okay, knowledge, value creation. Oh, CPD, okay. CPD pada, okay, all right. Okay, it's normal, okay, all right. So we want that CPD, right? Exactly. All right. Deep utility, good knowledge. Okay, all right. I think okay, that's all for our warm-up session. So I will touch ataupun saya akan sentuh sedikit mengenai biodata ataupun maklumat berkaitan dengan kita punya dua orang speaker pada pagi ini. So first speaker kita adalah IR HP Lui, Managing Director of Metricon Sdn Bhd. So basically Mr. Lui dia punya work experience dia adalah sebagai consulting engineer way back dah 42 tahun lah, way back from 1980 until now. Okay, through various consulting company. So Tan Sri Raja, Sri Zainal Empang, and then Metricon. Okay, so Mr. Lui also basically graduated from UM in 1979, and then currently holding professional engineer with PT license. Mr. Lui juga adalah jurutergas JBEG dan juga fellow IEM. Selain itu, Sri used to be secretary of ACEM for 2 sessions, 2003 to 2006 and 2009 to 2012. A founding member of GBI and NGBC, and also was in the GBI.AP up to 1916 and a past president of NGBC between 2014 to 2016. And currently active with CIRED from since 2000. Okay. That is Mr. Louis, our first speaker. So he is on the screen. Okay. Good morning, Mr. Louis.
Good morning.
Okay, all right. Okay, so our second speaker from TNB, IR Muhammad Rais, technical expert for PQEE. Okay, service experience in TNB since 2009 until now. So now, currently holding the post of technical expert in engineering services distribution network from 2020. So he graduated from Uni 10 and also have a master in engineering from Uni 10. Mr. Rais adalah professional engineer with practicing certificate and also competent engineer JK2 33 kV from ST. Also grid connected photovoltaic designer from SEDA, and lastly certified energy manager from IMAS. Okay, so that's all about our speakers untuk pagi ini. So kita akan terus ke sesi seterusnya. Okay, so this is the agenda. Okay, so sesi webinar kita pada pagi ini akan ada dua part lah, dua presentation part. First presentation from first speaker, Mr. Louis, and then kita akan break, and then we start back untuk second presentation part 2 daripada IRIS, and then after that kita ada Q&A session, followed by post survey and quiz lah, and then we are expected to end this session around 10:30 approximately. Okay, so please, to all the participants, bear with us. Okay, bear with us until 10:30. Okay, hopefully this fruitful session will give you more knowledge or more insight about the PQ. Before we start, this is some housekeeping rules. Okay, so all the participants will be muted, okay, when the presenter or moderator are speaking. This is to ensure there is no disturbance during the presentation. Okay, if you have any question to ask, please use the Q&A tools lah, to ask the moderator or the panelist. Okay, then pay attention to all at all the time, as there will be a token of appreciation lah for the quiz. And then kindly take a time to provide post survey feedback and suggestion for improvement at the end of the session. And last but not least, focus and enjoy the session. Alright, with that, I pass to Mr. Louis for the first part of the presentation. So Mr. Louis, the floor is yours.
Yeah, thank you. I'm starting my slide. Okay, can you guys see my slide? Yeah. Good morning, everybody. Yeah. Okay, can you today I'm going to talk about PQ, the fundamentals of PQ. As you can see, these are my topical subject I'm going to talk about. The first two part, which is the part which is defining what is PQ, The next speaker, Engineer Rai, is going to cover a bit, so I'm going to go through that very fast. And I think maybe I'm going to focus a bit more on item 5, practice examples. Okay. What is PQ? This is an analogy, you can compare PQ like supplying power as like supplying water. So if you supply water, Environmental Quality Act says that nobody is supposed to pollute the water stream. And I think, I'm not sure whether there's a standard that SPAN or Selangor is supposed to supply consumer with water with a certain minimum standard. So similarly, we have the same, but we are only not very sure whether the law requires consumer not to pollute the public network. But there's a law, the Greek code, which requires that electricity supplier should supply electricity to consumer at a certain minimum standard. Okay, PQ is a multi-dimensional issue. It looks different to different people. Later, as we will see, as I've said, this part, Engineer Rai is going to cover again in a little bit more detail. But sometimes people are confused because there are two words here. One is called EMC, electromagnetic compatibility, and PQ. And really PQ, as later you'll see, is a subset of EMC. We can class all PQ or EMC phenomena into this 5 phenomena means event lah, kejadian lah, So low voltage, that's the frequency limit. How is defined as high frequency or low frequency, And as you can see, conducted low frequency phenomena, PQ is mainly voltage disturbances. And as I've said, PQ looks different to different people, So from TNB side, PQ is mainly about voltage fluctuation. Whereas nowadays, to consumer, especially in Industry 4, PQ may be about harmonics, and transient. Okay, PQ, EMC, this is a general definition. If we have an environment, we have equipment which generates disturbance or which is susceptible to EMC disturbance. So that is the EMC environment. So electromagnetic field, fun facts, electromagnetic energy is actually one of the 4 forces of the universe. First is strong nuclear force, weak nuclear force, electromagnetic force, and gravity. So these are the 4 forces of the universe. And electromagnetic force are actually responsible for all happening like chemical reaction, and life itself. So again, this is a depiction of the EMC environment. You have signal exchange through a media. If conducted is through cable, if it is radiated through air. Okay, I'm going to skip this. So Engineer Rai is going to cover this on more details. What is flicker, surge, dip, and power failure. And harmonics. Now, currently, if for those design engineers, and especially in the semicon industry, harmonics and transient and something called ESD, like electrostatic discharge, is a major issue. So harmonics is a distortion of the waveform. And if you remember your basic electrical theory, any waveform can be actually summed up as a Fourier series of signal. So total harmonics distortion is a metric to determine how much distortion in a fundamental in Malaysia is 50 hertz. In other countries might be 60, Main source of harmonics, non-linear loads. Okay, these are some example. You can see, okay, the next slide. The higher the pulse, the higher the pulse rate, the less the frequency. And you can also see, like a 6-pulse rectifier, if you add a choke, add a choke, the choke actually acts as a filter, a harmonic filter. The fifth harmonic is actually reduced by half. Back to electrical theory, the number of pulses is actually how they shape the waveform. So less pulse means the waveform is less smooth, so which means it will give more harmonics. So that's the fundamental theory. Impact of harmonics. You find heating of equipment, temperature rise, cable increase, and especially third harmonics. Third harmonics is what we call a zero sequence phase. It will cause a high neutral current, and I think in standards, wiring standards, they recommend that your neutral, if you assess that you have an issue of third harmonics, then your neutral size must be maybe even full size. Okay, truncheon is when you have a sudden surge, which cause a spike in the voltage, a pulse in the voltage or current. Okay. Truncheon can be caused by switching, capacitive switching. Nowadays, as you know, all our lights are LED, and LED lights are capacitive in nature as compared to fluorescent, which is reactive in nature. So if you have a power failure and then suddenly you switch on a massive load of LED lights, you're going to get a spike in the voltage, which can cause a failure of insulation. Whereas this is how lightning-induced truncheon looks like. Switching of inductive loads. Okay, I'm going to skip this. Now, ESD is especially for those design engineers. We will design a facility with what we call pain. The pain will be anti-static pain, anti-static pain, and that kind of stuff. So ESD. So for those who are designing for semicon, okay, this is one concept people must understand. What is coupling? Coupling is when a signal, a disturbance signal is transmitted from either a source to an equipment. And it can be either radiated or conducted. Now, in this case, we have in the conducted mode, we have actually two kinds. One is called differential mode, and the other one is called common mode. This is what we call a circuit representation. Now, if we actually look at it, this one is clearer. Differential mode is usually lightning, when a signal is discharged, for phase and neutral, both in the same direction. Whereas in a differential mode, a switching surge occurs on the phase and then returns through the neutral. So that's called differential mode. So standard, I have a detailed list of standards which are not included in this slide, but which will be included as a handout. So the most important committee we are talking about is the IEC, and the other one is CIRED, CIRED, which is the International Committee on Radio Interference. So standards, simple concept standards. You have standard technical report. Usually standards are mandatory. If it is cited in law, it's mandatory. But in theory, standards are voluntary. But if it's cited in law, it is mandatory. And in standard itself, standards are what is supposed to be mandatory, and report and guide are just voluntary guides, So basic standard, generic standard, this explained here. Okay, these are the list of the IEC 6100 standards. I have a detailed list which is actually included in the handout. You also have mitigation, immunity standard, and for practitioner RCD, how do you specify RCD? Because RCD is a common issue in for those who are practicing in the especially design engineers, SEMI F47 is a very important issue. It is also mirrored in 61,000 part 4, but SEMI for F47 has a higher standard. Because PQ is so important. Back 10 years ago when I was practicing, PQ was mainly about voltage sag and dips in heavy industry. But currently now, from the new millennium, is increasingly start to talk about 61,000 part 4, truncheon, harmonic, and so on. So it is now mandatory. If you want to become a submitting engineer, you must know. You cannot say you cannot know. So this is the detailed syllabus. Okay, the economics of PQ, 3 direct costs, indirect costs, and social costs. Direct cost is loss of production. As in my experience, I did a plant in Chennai, India, and the first thing we try to find out is what is their PQ, what their reliability of supply. And we found out that in Chennai, it's supposed to be a high-tech park, power failure at least once a week, not on a weekend, on a weekday, So once a week, the staff get a free holiday. That's a direct cost. Indirect cost will include you have to institute PQ prevention measure because your production stopped, your income become postponed. Social inconvenience. Imagine, I think many years ago when my internet connection used to be modem, so every time there's a lightning strike, I have to run upstairs to switch off my modem. So that's the social cost. Okay, case study. Okay, I'm going to spend a bit more time on that. Now, the design engineer conundrum. How do you deal with PQ? This is a roadmap. Every design engineer must know. You cannot say you don't know. No? So this roadmap is actually from part 1 to part 8 of the IEC 364. How you do design, you assess, and then finally you do verification. The end result is the safe installation. So that's where PQ comes in. Now, the first case is starting of large motor. If you are doing a port, this was actually a study I had to do for a port in Johor. They got a crane, a Goliath crane, 1,500 horsepower. So we have to actually calculate every time you start the motor, will it cause a dip? And I think there's a limit under the standard. If it is connected PCC at 33 kV, it must not be more than 3%. If it's 11 kV, it must not be more than 2% or 5%. I can't remember. So to do that study, you must know how to do short circuit study. So sorry to those of you who are practicing, you must know how to do short circuit study. And we concluded if you are doing connecting large motor, more than 1,000 horsepower, you must connect at 33 kV. So other industry which use large motor is actually oxygen plant, like I used to do for air product. Their motor is something like 1,000 horsepower. Now, a very strange fact is in the building industry, aircon, usually 1,000 ton. You know, you have three numbers of 1,000 ton. 1,000 ton is about 1,000 horsepower. You know? And because aircon are designed by engineers, all the aircon chillers are low voltage. But usually, as an electrical engineer, instinctively, if we have any motor more than, let's say, 100 horsepower, we will either connect 6.6 kV or 11 kV. So, yeah. Now, resonance with source. A good example is if you have a lot of PV, you know, example was Hawaii, you know, a decade ago. They were the leader in mounting PV, you know, because Hawaii electrical system is relatively small. That means their generation level or short circuit level is much less lower, you know, than ours. That if you have a lot of PV, when you switch on the PV, it's going to cause system instability. So because of that, resonance study is actually a requirement if you are installing a large PV installation in Malaysia. So another case study, protection. Usually, protection. You see, if you got armored cable is shielded, if your building is maybe steel deck or you have concrete with RC. So the RC actually within the building acts like a shield. So now in this case, this was a real case which occurred back in somewhere in the mid-90s, I believe. Yeah. I got a call, you know, their equipment keep burning, you know, this equipment D keep burning, you know, and then they say cannot be, well, because they put surge arrestor, the design engineer very smart, put surge arrestor, but how come this D still burning, you know? And what happened was that this roof was a timber roof, so no shielding, and because this cable was exposed, and it caused actually, so what happened is you put a surge arrestor here. So, okay. Another case is in building, you know, in building. Commonly, people do like that or like that. These are not allowed because if you do like that, they may exist within the building, maybe equip a potential difference between the common earth, you know, the LPS and the protective earth. Protective earth is actually the electrical earth. CS might be the communication earth. So you cannot do this. We said this not, and then this is definitely not good. So currently the practice is if you have different power communication earth, then when it comes to you ring it up around the building. I think it's the same in substation. We have a ring of earth. Okay, correct. Now this is a case which is becoming common, you know. I was actually the project manager for the Ministry of Education. We were actually designing a lot of polytechnics, and computer labs are becoming very important. So I'm sure those of you who are design engineers, you know, you got a classroom which got 40 computers. In fact, we got one case, you know, the dean call, his lab keep tripping, you know. When the chargeman come, fix no trip. After the chargeman balik, it trip again, you know. So what happened is usually one computer has a leakage current of 1 milliamp when it's hot. So that's why it's intermittent. When it's not hot, it may be less than 1 milliamp. So if you got 40 computer, you have 40 milliamp, and your RCD is 30 milliamp, you know. So when you start, maybe no problem. When everybody hot already, all the computer hot, you know, everybody working, you know, then you get to start tripping. And this is another case. This happened actually to a karaoke lounge again back in the mid-90s. I was called because my client complained, you know, no, his karaoke lounge, you know, it tripped only at midnight, you know. Other time, 10 o'clock don't trip, but at midnight trip. So I think this problem lasted like 6 months. You know, they call it bomoing. You know, tripping at midnight. You call bomo lah, you know, or you call the Shinto priest or whatever lah, you know. it still didn't work. Finally, they called me and we troubleshoot, and this is what we found, around we got a controls room, and they were linked through because the video monitor must be linked, and what we found was that the red phase and the blue phase, so we changed it back to blue phase and the problem disappeared. So, but we actually have another case, not karaoke lounge, but something similar. You have actually a communication, a potential loop, which can cause, this problem. Okay. So, if you're a design engineer, you actually, before the installation is even up, you actually have to evaluate what you must do. Am I supposed to put a harmonic filter or maybe a SVC, And usually if you go to the web, you find that, to find out how to mitigate harmonics, you have to measure how much harmonics. But if you're designing how to measure the plant is not even up yet, So IEEE has actually a recommendation on how you evaluate. And again, short circuit study, system study, skill is a must. Lastly, macro statistic, understanding what is CIRED and CIRED. I think the next speaker is going to talk about that. Now, this is very important because if you're an investor, remember, as I said, I did a project in India. I also did a project in China back in early 2000 in Suzhou, Suzhou Industrial Park, and as you can see, in China, the CIRED is not so good. But really speaking, you actually have to look at specific. For example, if you look at Australia, the CIRED is really bad, compared to Malaysia. Malaysia is pretty good, that's why semicon industry stay in Malaysia. Now, back in the 90s, mid 90s, some of the semicon industry wanted to move to the Philippines, the Philippines. There you can see at the back here. And if you look at CIRED, this idea was dead on arrival, so they have to come back to Penang, no choice, because of the CIRED. Now back to China, what we found was that in certain industrial park, even though the national average may be high, but certain industrial park, the China did a pretty good job of actually maintaining CIRED at their certain industrial park. Which is not the same for India. Even at Chennai High Tech Park, so India cannot have semicon industry until they improve the infrastructure. So this is what you need. So with that, I end my presentation. Thank you very much. Okay, back to you, moderator.
Okay, thank you, Mr. Lui, for the presentation.
Yeah, just nice, 30 minutes.
Just nice, 30 minutes. Okay, thanks. Right. Okay, so we're gonna have a break. But then sebelum break, saya ada some info lah untuk kita cerita. Okay, so kita akan highlight sedikit on the CIRED membership. So since kita nampak tadi majority of us lah, okay, majority of us yang join this webinar is not a CIRED member yet. Okay, so we want to highlight CIRED to all of us. So basically the benefit of joining CIRED is, number one is the members will be updated with new technologies and latest technical knowledge in power distribution industry. Okay, members will be aware of the current practice framework with respect to the Malaysia Electricity Supply Industry, or MESI, which is currently is MESI 2.0. Number three, members from local industries, manufacturers, suppliers are well informed on the needs and requirement of MESI 2.0. And also members are encouraged and are given a platform to have open discussions on issues pertaining to MESI 2.0, especially dialogue between utilities and energy-related industries. Okay, how to join? Basically, fill in the form. joining as ordinary or associated member or collective member. And then we need to pay the one-time entrance fee and annual subscription fee. So for ordinary and associate members, the fee is one time 200 for entrance fee and annual subscription is 100. Collective membership, the fee one time entrance is 400 and annual subscription fee is 600. And then you can send the form and also any inquiries to CIRED regarding CIRED membership to mashita61@gmail.com. Okay, so this is the secretariat for the CIRED. Okay, so hopefully after this we can start to get the form and fill in and become a member of the CIRED. Okay, this is a message from the CIRED. Okay. Okay, so we also want to highlight the series of webinar, the TNB CIRED ACEM webinar series. So we currently plan a 5 webinar session. So this PQ is the number 3. So we will have another 2 this year. IEC 61850 on 12th May and also distribution automation on 9 June 2022. So this webinar, as we all know, is open to all CIRED and IEM members. So save the date. We will meeting you soon for this last 2 webinar series. Okay. Okay, before we go to break, just recap for those yang masuk lambat. Please fill in the attendance form. You can scan QR code and also get the link from the chat box. Okay. So with that, kita take a break about 5 minutes. Okay. Thank you. Aduh.
For more than 5 decades, ACEM's been focused on advancing professionalism and affecting change, because that matters to you as a professional, a consulting engineer. Regulations, status, influence and command. The Association of Consulting Engineers Malaysia, ACEM, has looked out for you through many milestones passed by our nation. Our quest started way back in 1963. Now we're headquartered in Kuala Lumpur with branch offices in Kuching and Kota Kinabalu. Come join us and be counted. Our goal is about empowering, looking into your interests, rights and privileges, availing a platform for your voice to be heard with the government, public bodies and industry associations, as well as extend cooperation with related bodies and stakeholders. When it comes to being a member of the Association of Consulting Engineers Malaysia, ACEM, it's about being involved and keeping abreast with our profession. From a membership spanning sole proprietors and partners of engineering consulting practices, ACEM is the reference point and influencing factor, driving matters that affect consulting engineers in our country. With 900 individual members and 470 member firms, representing in excess of 20,000 employees, ACEM has the clout to become a formidable partner to be aligned with. We're heard in over 90 committees and work groups, and that includes ministries and local governments, government agencies, and related associations. ACEM's reach also ensures a voice in regional and international matters as well. Advancement of the consulting engineering profession is the essence of ACEM's existence. Working through standing committees and the Secretariat, ACEM continually provides a platform and paves the way, affecting and courting change. Our track record spans more than 50 years as a sole catalyst, augmenting the role of the consultant engineer. There have been many. The delivery of the Manual Perolehan Perkhidmatan Perunding 2011, which instruments the upward adjustment of government-approved salary scale. It was us, QBS, as a government procurement policy. That was us too. Ad valorem stamp duty on construction agreements and BEM ruling on stamp duty. ACEM's insignia was clearly there too. And what about the future? Our relevance was also captured in the Green Building Index, GBI, for Malaysia. We believe in addressing what is needed. At ACEM, we believe that the consulting engineering profession grows in stride with ongoing global developments. We lead the torch in facing hurdles and charting the way towards a more efficient and effective profession. Because with ACEM, not one of our professionals gets left behind. Like a flame that never dies, ACEM is hard at work, overseeing and monitoring the landscape. Quite often, we're prompted to anticipate concerns and initiate engagement, like the implementation of the REA 2015, which allows liberalization of the industry, push for complete liberalization of consulting practice, urge for regulations requiring local participation in FDIs, promoting green initiatives in the built environment for waste reduction, resource conservation, sustainability of ecosystem, and improvement of quality of human life. Safeguarding fair and equitable treatment to all stakeholders involved in the construction industry, and encouraging technology adoption for the efficiency, productivity, and advancement of the construction industry. ACEM, for the betterment of future generations. Your participation is our advancement.
Okay, welcome back. Okay, hopefully kita semua ready untuk the next part of the presentation or next part of the webinar. So we have the second presentation by Ahmad Rais. Okay, so with that I pass the floor to Ahmad Rais.
Assalamualaikum and very good morning everyone. Thank you Encik Shahi for the nice introduction. Okay, my topic today is about PQ Taskforce. However, I would like to educate my audience first on the power quality. What is power quality about? Focusing on Voltaic Sac. First of all, in ideal case, we have a nice sinusoidal wave from the power station, sending all this nice power sinusoidal wave to every industry, every customer. Okay? In ideal case. However, sometimes the voltage is not normal. It's what generated from the power source due to certain things. So the normal condition will be a nice sinusoidal, but the abnormal condition will be the sinusoidal on the right here. Okay, many types of non-smooth sinusoidal, and this is considered abnormal condition. And the normal condition for voltage is like this: 33 kV and 11 kV is plus minus 5%, and for 400 and 230 is plus 10 and minus 6%. So in ideal case, a nice sinusoidal is transmitted from the power plant to the transmission line and distributed nicely to every customer connected to the grid. So some of the not nice sinusoidal wave are shown here. As you can see here, the first one is the voltage dip or voltage sac. We can see that the sinusoidal have reduced a bit here. This is considered a voltage sac. Momentary interruption. You can see here some of the sinusoidal is somewhat lost. We don't know where it's been. And the swells. Swells meaning the sinusoidal wave have increased a bit. Transient, we can see some spike here. Harmonic distortion, as explained by the previous speaker, a bit jagged. The sinusoidal is a bit jagged, and not just having some spike, repetitive spikes. Voltage fluctuation or flicker, having uncertainty of voltage variations, and the frequency deviations, the frequency adjusts itself. So, based on the standards, we consider swell and swag. Today, my slide will focus on sag. So, voltage sag is actually defined as a short duration from 10 milliseconds to 1 minute for voltage deviation 90 to 10%. So, any voltage that falls below 90% of the nominal voltage to 10% of the nominal voltage is considered sag. So, what are the symptoms of voltage sag? Light to dim or blink for a short duration, and some sensitive equipment may stop, and some sensitive equipment which does not have enough immunity will stop. So, what causes voltage sags? Any disturbance can cause voltage sags, such as weather, weather, lightning, lightning strikes the bare conductor of the transmission line, can cause voltage sag. Equipment failure. In our substation, we have so many equipments. Equipment failure, the VCB, the transformer, any equipment failure can cause voltage sag. Vegetation, okay, a tree fall onto the bare line or any other lines, insulated line, can cause voltage sag. Third-party damage, such as people working near the lines, can cause voltage sag. Animal encroachment, animal standing next to a conductor, bare conductor, can cause shortage, then cause a voltage sag. Excavation, people excavate to lay fiber, to lay new cables, to do works, to do road works, and then hit the cable, can cause voltage sag. And also sometimes customers also internally can cause voltage sag that will affect everyone. Okay, so these are some of the causes of the voltage sags. Okay, so mostly voltage sags are caused by electrical faults. As you can see here, this is a switchgear. They have some fault in it. There's a burning fault. There's a burning burning color here. Yeah, underground cable joint, some fault here. Flashover of equipment, the transformer flashover, and lastly, the lightning strike. Lightning strike can cause voltage sag. So, how long does this voltage sag last? The voltage sag lasts until the fault occurred. As you can see here, this is the current during the event. Starting from the fault occurred, we have a very high current. So when we have a very high current, the voltage drops significantly. And then the voltage sag will continue to, the voltage is reduced. It reduced here, you can see here, is reduced from here to here, for as long as the fault cleared, until the fault is cleared. So this will be the duration of the voltage sag. And it will continue to dip. The voltage will be below the nominal voltage until the fault is cleared. So we understand that voltage sags are mostly are caused by electrical fault. So this is some infographic I would like to share with my audience. Say an example. We have a typical grid, TNB grid in this case. We have the power station, we have the transmission, we have the distribution, and we have our customers here, LV and also MV customers. So you can see here, this is the voltage sag severity indicator that I make color like this. So red being the worst, red being the worst, maybe 10-20%. And green means okay, okay, which is between 80 to 90%. So you can see here, number one, let's say a feeder fault here, 20 km from the substation. When there's a fault here, we understand that fault can cause a voltage sag. So the the bus bar at the substation here, which is 132.33 kV, will cause a voltage side. The voltage will drop. The voltage will drop. Okay. So here, the substation here, as you can see, is a pink color, have some severe voltage drop. And then the adjacent feeder, the substation connected to the same bus bar here, which is this substation, 3311, will also experience a voltage drop. In this case, voltage drop, voltage drop. And the severity is also the same as here. And any substation or customers that connected to this substation also will experience voltage side, especially customers with not enough immunity. They will experience voltage side. Okay. Then followed by this, another transformer for our low voltage customers. Since it's connected to the same bus bar here and the same bus bar here, also be affected by voltage side if they don't have enough immunity. So this is a 20 kilometer fault. This is 20 kilometer. However, as you can see here, the customer connected to the next feeder is a different transformer and different bus bar, may have some effect, but it's still in the green zone, maybe around 80-90% voltage side. And the transmission is not severely affected. Yes, there will be some drop, depends on severity of the fault, but it's still in the green zone, right? So this is an example for voltage side that happens 20 kilometers from the substation. Okay, so let's see another example. The same fault that happens here, the feeder to this customer B. However, the distance is nearer to the substation. It's about 5 kilometers from the substation. Since the fault is very near to the source, to the substation, there will be a very severe voltage side. As you can see here, it's a dark red. It's a dark red. So again, any substation or customers connected to the same bus bar here, for example, this substation here, and customers A and C, will actually experience a voltage side if the customers doesn't have enough humidity. And also the LV customers, which also connected to the same bus bar here, also will have a severe voltage side if not having enough humidity. Okay, so we can see here the customer here may have some effect too, but somehow it's still in the green zone. The 132.11 connected customer here may have some effect, but it's not as bad as the customer connected to this bus bar. And transmission connected is still in the green zone. Okay, so we know that we can from this diagram we can say that the voltage side severity depends on the fault. So we know that higher fault, the closer the fault to the source, the higher the fault is, and the more severe the voltage side. Okay, another example. Fault at the transmission line. Okay, fault at the transmission line. Let's say we have a big transmission line here connected everywhere. So let's say there's a fault at transmission 132 kV. Okay, so the transmission line same. Since there's a fault here, there will be some voltage side. However, since the transmission line is quite distance away from the source, maybe the drop, the voltage side is not that severe. It's still in the green zone, and it will affect all the connected substation. So you can see substation here, substation here, and then any customer that doesn't have enough humidity will also be connected. However, it's not as severe as the previous example. As you can see here, most customers are still in the green zone. We can see that the severity is not that bad. It's still in the green zone because of the distance of the fault. So it's advisable for customers with sensitive equipment to have enough humidity to ride through any voltage that happens. We will share that later. Okay. So some mitigation, the mitigation, voltage mitigation is not solo lah. Doesn't depend on one person only. It depends on the four. In this case, it's 4%. The utility itself needs to play a role. The utility itself needs to play a role by having a good electrical environment to reduce the fault occurrences, to reduce the fault severity, and utility needs to make awareness program to make the customers understand. Customers also have a role to play in mitigating voltage sac, which is to purchase equipment with a specification that can ride through a voltage sac event if they have a sensitive machinery, and also may install mitigation equipment. May install mitigation equipment if they have a sensitive equipment that unable to work during a voltage sac. So from the equipment manufacturer also have some role in mitigating voltage sac to develop equipment with immunity capability that can ride through voltage sac. So this triangle shows that voltage sac mitigation is not a solo program. It needs to be from all parties. Regulator also have a role, which is to regulate the utility, customer, and manufacturer, and so also produce some awareness program. So all relevant parties have their own role in mitigating voltage sac. So when we talk about mitigation voltage sac, we always talk about PQ mitigation equipment, such as leak-free system or any other equipment in the market. But you can see here, this is the cost for the solution. It's 10 times to the power of 2, 10 to the power 3, and the low knowledge of equipment sensitivity. Okay. For utility solution, for example, the utility wants to install mitigation equipment, it will be very high cost because the utility will cover all the load, which includes maybe the toilet, the canteen, the compound, which is non-critical when voltage happen. So the best and the most the less cost will be at the machine solution or control solution somewhere here. However, when we want to mitigate this area here, which is in the control, knowledge is required. More knowledge is required to understand how the machinery works, to propose a proper mitigation equipment. So this is the mitigation general. So it's advisable to install equipment to mitigate voltage sac at the nearer to the sensitive equipment, nearer to the load, due to cost. Okay, so ST have come up with the index to measure the severity of voltage sac. They have come up with the index, which is called SARFI, System Average RMS Frequency Index. So SARFI X means the percentage of the voltage sac. So let's say SARFI X is SARFI 90. Okay, let's say SARFI 90. It's actually bilangan kejadian voltage sac di bawah plus 90% dalam TNB divided by the bilangan alat perakam, which is the recorded numbers. The recorded numbers. We have some PQ recorders installed in our network. So multiple PQ recorders. So let's say 90%. So divided by number of power quality recorder that record below 90% voltage sac. And then this is for the whole TNB. SARFI X TNB is for the whole TNB satu Malaysia, which under TNB lah. So SARFI X for setiap negeri depends on negeri divided by the number of recorder. Okay. So this X actually can go down to 90, 80, 70, and so on. We will see on the next slide. So this is the performance of TNB power quality performance of 2019. We can see that the SARFI 90 is about 10.13, meaning 10.13 voltage sacs happen for an average of 10.13 voltage happen for 1 year. And SARFI 80 is 3.02. SARFI 70 is 1.21, meaning only one, on average, one voltage sac that happens below 70 per year, 1.21 on average, and so on. So SARFI X meaning 90, 80, 70, 50, 40, and 10. Okay, in terms of trending, we can see that the last 3 years, from 2018 to 2020, the SARFI has dropped. The SARFI has dropped quite significantly, especially SARFI 90, that's quite significantly. From 2018 is 15.1%, 2019 is 13.73%, and 2020 is 10.13%. Same goes for the SARFI 80 and 70. It has significantly dropped from 4.52 in 2018 to 2.19 in 2019 and 3.02 in 2020. Also for SARFI 70 also dropped 1.71 to 1.38 and 1.21. So we can see the trending as a big drop from 2018 for the last 3 years. Okay. So this graph shows that the occurrences, the red, yellow, blue is the phase, and this one is the voltage percentage. So you can see from here, most voltage sac happens in the upper region from this table. This table represents the immunity curve. So most voltage sac happens above the immunity curve. So by right, customers who have enough immunity and follows somewhat this immunity curve won't be so much affected. Okay. So what in TNB, what are the main causes of voltage sac? The top contributor will always be the cable, because we have so many underground cables and overhead cables connected. So the top contributor is cable fault. So cable fault is combined with excavation and joint failure and other cable failures. So about 90% breakdown in distribution network is related to cable, because so many cables in distribution network. The second contributor is transient fault. Some permanent lines have the bare overhead line with auto recloser. So normally caused by lightning or animal encroachment. Then auto recloser will close back when they detect a fault. So we can say that 90% is due to MV cable breakdown because of the number of quantity of cables in distribution network. So what TNB have done to mitigate power quality? So we work in hand with our customers to mitigate power quality problem, to manage compatibility issues. So number one, a PQ task force, a pilot PQ task force was established 2019. It's a collaboration based on best practice on TWGE benchmarking visit. This one I will share in the next slide. So this is a platform. This is a platform for both party, customer and TNB, to discuss and share mitigation action plan for voltage issue. So TNB also have annual PQ briefing and awareness. This is to educate customers on power quality problem in general and what action so for the customers to take. About 133 sessions was conducted in 2020. Besides that, we also have PQ service program. We give consultancy or advisory service. We do complete investigation, testing, and mitigation equipment. And lastly, through our subsidiary, TNBS, offer leasing package on PQ mitigation equipment. This is to ease customers' financial burden. So customers have can purchase the equipment outright, or customers can do a leasing package under TNBES, our subsidiary. So other things that TNB is doing to reduce the voltage sac is, as I told earlier in the previous slide, the main cause are actually faults. Mostly are caused by fault. So TNB have done many action to reduce fault, which is condition-based maintenance, such as PD mapping. Remember that cable is the highest contributor. Preventive maintenance, tower footing resistance, vegetation management for overlay height, and cable routing, patrolling, and third-party digging management, PDYD. So these are all the things that TNB done to reduce voltage sac, to reduce fault, in thus reducing the voltage sac occurrences and severity. So this is in line with TNB's program, CIRED 50 and ZETA initiative. Okay, now the main topic for today is the PQ task force. I hope all my audience already understand the definition, what is voltage sac, and what happens during a voltage sac event. So now I will share about the PQ task force, the pilot PQ task force that was done between TNB and a customer. So, in order to engage customer in managing power quality issues, TWGE, which is Technical Working Group of Getting Electricity, perform a benchmarking. So TWGE has performed a benchmarking, and from the benchmarking, tried to adopt the best practice by other countries by forming a PQ Task Force Working Committee and PQ Executive Management Review. So from TWGE, they form two committee below, which is the PQ Executive Management Review team and the PQ Task Force Working team. Okay. So the PQ Executive Management Review team is decision for making the decision for making improvement, option, and implementation. The members are from ST, TNB, customers, and also MPC. So TNB was highly involved in this PQ Task Force Working Committee. So in this Task Force Committee, the function is to undertake root cause analysis, evaluate cost, benefit, and risk of PQ improvement plan. So the members are from TNB, customers, and also MPC. So since this is a pilot program first, so PQ Task Force Working Committee actually is a bi-monthly collaboration between TNB and customers to discuss the cost of Voltaic Sac event and the relevant party to take by both party, customer and TNB. 9 meetings was conducted from the starting of the creation of PQ Task Force, and the meeting agenda focuses on these 3 things: overall performance, cost and action plan update by TNB, and action plan by customers. So before this PQ Task Force can be created, an NDA needs to be signed. So when an NDA is signed, some of the sensitive information can be shared between these 2 parties, which is the customer and TNB. So some of the action plan decided by customers and TNB. So with this PQ Task Force, we discussed that some of the action plan to improve the Voltaic Sac is tower grounding system improvement by TNB, overhead line lightning performance study by TNB, aging underground cable replacement by TNB, switchgear gas related refurbishment by TNB, oil impregnated paper YP bushing to resin impregnated bushing replacement by TNB, and also customers to immune equipment hardening to comply to SEMI of 47 customers action. So again, like I said earlier, this to mitigate Voltaic Sac is a tri-party. So customers have their own role, and utility, in this case TNB, have their own role. So we have updated the PQ Task Force Working Committee, and the PQ Task Force Working Committee update is the pilot is deemed successful, and collaboration was complemented by all parties involved, and active involvement by all parties. And way forward, same model to adopt by other customers, and the proposal to be tabled to the next TWGE meeting. And the pilot's success story will be shared to relevant parties, IEM or CIRED, which we are today sharing the success story. So TWGE also congratulated PQ Task Force Working Committee on success collaboration and appreciated the transparency promoted in every meeting. So the conclusion. So the conclusion is a good collaboration will benefit both parties because more idea and more knowledge can be obtained and discussed. So with discussion between 2 parties, the utility and customers collaborate to have more ideas. Okay, what can you do? What can you do to mitigate this? What can I do to mitigate this? So some ideas can be discussed and shared because there's transparency. Okay? So by having enough information on the Voltaic Sac event, both parties can take the necessary action. So knowing what is the main cause of the event, both parties knows what to do. The utility knows what to do. The customers also know what to do. So, and then number 3, to protect both parties, a non-disclosure agreement is required to ensure confidentiality is contained. This is the main thing, because some of the information are strictly confidential. So by having an NDA, more transparency are there, so more information can be shared. So the working model TNB and customer is successful, and the same model to be adopted in the future for collaboration involving other parties. So that's all my side for today. Thank you for listening. I pass back to you, my moderator.
Okay, thank you, Mr. Rais, for the presentation. So hopefully, we have an insight of what is PQ Task Force is all about. Okay, so basically, the next session is we have a question and answer session. So feel free to ask any question to our panel. So I think we are now approaching 10:30. So maybe one or two questions we can take to answer. Meanwhile, while waiting for the participant to ask the question, I think we have some question to our panel to answer. Okay. First of all, a question to Mr. Lui. The question is, should design engineer incorporate the PQ mitigation equipment such as harmonic filter, Voltaic Sac mitigation equipment during the design stage for the identified sensitive equipment? Okay, so this is the question for Mr. Lui.
Yes, my answer is yes. To go to that, I think I need to go back to one of my slides. One of my slides. Yeah. Okay. Yeah. Can you see? Yeah. So if you see the design engineer's conundrum, conundrum means issue lah, problem lah, masalah lah. No? Okay. What do you do? Okay. Okay. Can you see my slide? Okay. Okay, no, not this one. You actually have to make an assessment on okay. If you're a design engineer, this is the roadmap on how you design a safe installation, and within all the roadmap, you must consider source of PQ. So back 10-20 years ago, PQ was not so much of a serious concern, but currently because of Industry 4, because even now, your office, last time in the 80s, my design office, no computer one, all my drafting office, I got 20 people there doing drafting. Now I maybe only have 10 computers and maybe 5 people doing the job of 20 people. So as I've said before, computer lab, you have 40 computers. So in an office, you have a lot of computers. So you actually have to assess. And of course, Voltaic Sac, principally if you're dealing with heavy industry, like if you have large motors like compressor plant, a lot of compressor plant are something like 1,000 horsepower. That's my experience, if you're doing maybe like in a port, port, they have crane which is 1,000 horsepower. So you actually have to do a study, and this is and this question I cannot answer within like 10 minutes. There's a whole course on how to do mitigation for the design engineer, how to estimate harmonics. For example, in an installation, lighting is about 25% of the total load. Now, if you use LED, maybe it becomes 15%, but LED is mainly capacitive load. Remember what I said about switching. So you actually have to think about whether you need to do a filter and so on. Yeah, so it's cannot be answered within 15 minutes. So okay, stop sharing. Yeah, I think I hope that answer. So this is much more. You actually have to engage me for like another 45 minutes presentation to tell you, what are the things you should do. I hope that answered the question. Thank you.
Okay, thank you, Mr. Lee, for the answer. Okay, so we have another question. This one for Mr. Rais. The question is how to ensure sensitive equipment meet the immunity promoted by the standards.
Yeah, thank you, Cheshire, and thank you for the person who asked this question. Okay, let me give an example. You don't know what you are sick of, you go to the doctor, so the doctor will check what's the matter with you kan. So it's the same with the equipment it's the same equipment. We can do a right-through test. So we can do a right-through test. There's an equipment actually that simulates voltage sac. We have one. So it actually simulates a voltage sac. So we can select what is the severity of the voltage sac and select. Then we can know what is the equipment's sensitivity or what curve does it follow. So again, to know this immunity is to test. The only way to know is to test. Thank you.
Okay, thank you, Mr. Rais. So we have a question from Mr. Prabha. So what is recommended SciFi values free from Voltaic Sac? So I think I pass to any of the speaker to answer.
Okay, let me try to answer this question. What is the SciFi? I think SciFi values from free volts. Okay. Let me iterate that voltage sac is something inherent in the system. It cannot go away 100%. It cannot go away 100%. However, like COVID vaccine, we can have some vaccine We can have some vaccine in terms, meaning that we can have some immunity, a protective device. So there's no standard saying what should be the SciFi values. But again, if we have a sensitive, if your factory has sensitive equipment, therefore it's recommended to have mitigation PQ voltage mitigation equipment, so that you will not experience any downtime. Right? Hope that answers that question.
Can I add on? Can I add
Yes.
on to this? Yeah. Okay. Voltage sac. There's actually a standard, a recommendation. If you are designing an industrial plant, so if you are the design engineer, you actually have to take mitigation measure. I believe if your PCC is at 33 kV, I think the voltage sac limitation is like 3%. That means to say your equipment must not cause a sag of what is a sag? You go back to the definition. So something like I think it's 3% if I remember rightly. But if it is 11 kV, the sag is different because the short circuit level is different. So there is actually a standard recommendation way back. I remember back in the 80s, in the 90s, there was a lot of industrial plant, steel mill. If you're designing a steel mill, arc furnace, steel mill which have large motor, cement plant, the rolling mill has a large motor which is 1,000 horsepower. If the motor stop, you actually have to consider. And usually, if you connect at 33 kV, it will solve the problem usually. But in one case where we have a DC motor, 1,000 horsepower DC motor, a cold rolling mill, we actually have to install what we call a TQC, a thyristor Q control. As you know, the other method is what we call a SVC, saturable var reactor, to actually control the voltage sac. And there is actually a recommendation on that, 3% at 33 kV and so on. Thank you. And that is the design engineer must know. Otherwise, you get sued for negligence. Thank you.
Okay, thank you, Mr. Lee, and also Mr. Rais for the answer of the question. So I think we are running out of time for the question by the others that have not been answered, we will get the answer and pass back to you after this. Okay, so with that, we are moving to our next session or slot, which is a quiz. Okay, so get ready. Please join back the Slido. Okay, at slido.com. The code is #PQEE. Passcode is TNB123 or scan the QR code. For those who are interested to join the quiz, okay, we have some token of appreciation later for the I think top 3 best student. Okay, all right, not really best student. Okay. Okay, we give another minute to have a maximum number of participants. Currently it's 34, 36, 37. Still counting. 41, 43. Okay, 43, 46, 48. 51 out of 150. Okay. So about 30%. 62. Okay. I think we are good to go. All right. So, okay. Another one. 63. Okay. All right. 65. Okay. Okay. Approaching 70. All right. We go. We start our quiz now. So, the first question is, all right. Which statement is not true to describe power quality? Right. Lock. Sorry. There is some issue. Okay, sorry. We will come back later. We try to find out what is the problem. So give us some time. Okay. Sorry about that.
Energy is everything. Actions, intentions, drive. It's the life breath of all we build around us. The buzz that keeps us cutting edge. churning out the big ideas that make tomorrow cool. It feeds our hungry factories and fuels our enterprise. It fills hospitals with hope and schools with light. And homes it makes more home-like. Keeping comfort and convenience, modern genius has devised alive. It fills hospitals with hope. Visible, audible, incredible. This unceasing progress is over 14,000 megawatts and growing, sparking more than 9 million smiles countrywide. And now, as we leap into the future, as we reimagine who we are and how we work, it's here to keep us company, embracing technology, both ultra-modern and sustainable, like old familiar friends. And now, as we leap into the future, as we reimagine who First, we are and how we emissions work, must be cut. Our carbon footprint made far more planet kind. Being ultra-green is a universal goal, and we've long been on board with the idea of sensible renewables. Hydro is a given, yes, but now the benefits of solar beckon too. And whilst renewables are responsible, there's also respect for the wilder places and spaces our business sometimes takes us to. But green alone is not enough. Tomorrow's world needs smart as well. Hence, our grid is being upgraded, even as we speak. Our world networked for intelligent evolution of ideation and innovation, of man and machine. All we do is human-centric now. Energy consumption, for example, can be viewed in real time. This means absolute control over usage, minute by minute, watt by watt. All we do is human-centric now. And in looking out for the communities where we work, we're also looking far beyond Malaysian shores. Seeking first-rate opportunities, we're keen to maximize the skills we have honed and the know-how we have earned over 60 fruit-filled years. Our subsidiaries stand in line, ready to rise to any challenge, offering nuts and bolts proficiency all along the value chain. Each eager to venture into foreign lands and win business everywhere we tread. In power plant maintenance, refurbishment, rehabilitation, and repair, we're second to none. On the manufacturing front, our cables, switchgears, and transformers are all world-class. 36,000 strong, we are driven by our vision of a better, brighter world for all, as we aim to be a top 10 global player by 2025. As we grow towards that goal, we groom rank upon rank of business-savvy, global-minded leaders. This we do with scholarships, by plucking the best and brightest from our very own university, by keeping staff future-focused and future-ready at our in-house training institute. Elsewhere, we're busy honing our edge with R&D, exploring the full potential and possibility at our in-house training institute, in anticipation of what tomorrow will bring. Aware of the ever-present challenges of technological, digital, and regulatory disruption, we see success ahead. Simply said, we're a player in the global game of energy, equipped to collaborate and co-create anywhere and everywhere for mutual business benefit and gain with anyone and everyone, provided they're equally committed to this great pursuit of excellence, day in, day out, non-stop. We are energy at work. We are TNB. They're equally committed to this great pursuit of excellence.
Okay, kita try untuk quiz. This is the first question. Okay.
Boleh dah quiz. Boleh dah. Tapi tak keluar ni. Okay. nampak apa? Ni. Alah, dia tak start dia.
Alright. So, kita ada 82% jawab B, another 10% jawab A, and 3% C and 5% D. So the answer is B. Alright. Okay. Next question. Okay. So technologies Amir Firdaus. First currently. Okay. The next question is EMC means. You got another 10 seconds. Alright. Okay, 85%, answer C, 11, answer A, and 4% answer B. So the correct answer is C, electromagnetic compatibility. Okay, we see, technologies Amir Firdaus still leading the leaderboard. Alright. So the third question is the IC 61000 series in 6 parts. Specify what? Okay, A, B, C, or D. Okay. So 52% answer A, 22 answer C, 20 answer B, and 6% answer D. So the answer is A. Alright. Okay, Mr. Ken is leading the leaderboard. Alright, we have another 2 questions. Right. One essential skill for designing to PQ requirement are okay. So we have 39 answering E, 32% answering B, D, 14 B, 9% is C, and 7% A. So the correct answer is D. Okay, competency in short circuit calculation. Okay. Alright. So the ranking is okay now. ZZDDN is leading the leaderboard. Alright. So the last question is what caused the Voltaic Sac event in power system? Pick one. Alright. A, B, C, or D. Alright. So 52% answering D, 47 B, and 2% is A. So the correct answer is B, fault condition. Alright. Okay, so congratulations ZZDDN for becoming the champion for our quiz for this webinar session. So we will contact you and please state your details in the Q&A box for us to contact you. And also another 2, top 3, please share the same, your name and your contact info for us to contact you back. Alright. So with that, We are coming to the end of the webinar. So kita akan ada another last post survey to gauge or to get the feedback from all of you. Okay. So please tell us how about the timeline for this webinar. So 9 to actually 10:30, we are basically overrun about 50 minutes. So please, give your feedback on the timeline, on the duration of the webinar. Okay, so the next one is the presentation by our panels was effective and easy to understand. So please state your answer. Strongly agree, agree, neutral, disagree, or strongly disagree. Okay. So we get 42 response, 43. So we go to the next question. Okay, how about the understanding of the content of the webinar? So please state your answer. All right. Okay, I see Mr. On SH raise your hand. So if anything you want to ask, please write in the Q&A box. Okay, because we are not allowed for this session to be verbally asked as the panelists. Okay, all right. Just to control the timing of the session. Okay. So we go to another question. Sorry. Okay. Do you interested in participating in the upcoming series of webinar organized by TNB and CIRED? Okay.